Hello everyone, this is Subiksha, registration number 20 on MIS 1020. So I'm going to present a topic about natural language processing. It's going to be syntactical analysis. So to know more about syntactical analysis, we have to know about the process of natural language processing and the phases of it. So first, let us know a lot about the phases, and then let's look into what is syntactical analysis. So what is NLP? NLP is the branch of computer science, which is the base for different uh, fields like human language and artificial intelligence. So, machines use these NLP technology to analyze and interpret the languages which is used by the humans, and it also helps in assisting the tasks like translation, speech recognition, topic segmentation, and etc. So there are APIs that uses this NLP processing techniques, which include ChatGPT, which is a chatbot, and also Watson, which is developed by the IBM. And but these are the steps which is involved in the NLP. So first is the lexical analysis. So lexical analysis, the sentence is divided into different words, and in the syntactical analysis, the grammar is checked and the arrangement of words is checked whether it is arranged structurally correct. Semantic analysis focuses on the literal meaning of words and the phrases. Course integration depends upon the like the meaning of the sentence actually depends upon the sentence that precedes it. So that is what this in integration does. And pragmatic analysis, it means the abstracting the meaningful use of sentences in different situations and in different contexts. And first, let us look into the lexic analysis. This is the first phase of NLP, where the paragraph is divided into different words, and the words. I'm sorry, the paragraphs are divided into different sentences. These sentences are divided into different clauses, phrases, and then words. So it is the process of identifying and analyzing the structure of these words. For example, these words which are divided from the paragraphs, clauses, phrases. This word is the smallest unit of text, and it is called the token. And for example, let us take an example of the sentence, he goes to the college. So here there are five different tokens. He goes to the college. So there are five tokens which is involved in this sentence. So basically what lexical analysis does is it just divides the whole text into different words. And syntactic analysis. First, we'll have to know whether the sentence is grammatically correct, the ordering of words are proper, whether the words are arranged structurally correct. So all these things are done by this syntactic analysis. So in this phase, the sentence is checked whether it is well formed or not. It is checked for word arrangements and also the grammar. So basically, it is checking of the grammar in a sentence. For example, let us take the the girl to the school. This does not provide any meaning because it is not actually grammatically correct. So this will be rejected by the analyzer. So the if there is a sentence, the girl goes to the school, then it will be structurally correct, and this will be approved by the analyzer. Next is semantic analysis. In semantic analysis, the sentence is checked for the literal meaning of each word and also when they are arranged together. For example, there will be words which provide proper meaning when they are as a literal, but when they are combined as a when they're combined together as a phrase or something like that, it will not provide any meaning. So the work of this analyzer is to check whether it has a proper meaning even when they are together. Let us take the example of colorless blue. So colorless, when it is uh, defined as only colorless, it has a meaning which is it has no color at all. Blue, it also has a meaning. It is a color. But when these two words combine together, it does not provide a proper meaning because the colorless blue does not provide any meaning. It just makes no sense because colorless is something with a color and blue is a color. So colorless blue does not provide any meaning. So it will be rejected by the analyzer. And the coarse disintegration, it actually means that the meaning of the word, the meaning of the sentence depends upon the meaning of the sentence which precedes it. For example, let us take this. She wanted it. She wanted what? We don't know what she wanted, right? So we'll have to know the meaning of the before sentence in order to know what she wanted. So let us take she saw a doll. She wanted it. So we'll definitely know she wanted a doll. So this is what discourse integration is. So it depends upon the sentences that precedes it, and also it invokes the meaning. The preceding word, the preceding sentence, it gives the meaning to the sentence that follows it. And then pragmatic analysis. This is the last phase of NLP, and sometimes this is integrated, like this is combined with discourse integration to provide proper meaning. This mainly focuses on the reinterpretation of the sentences. For example, here it is given as close the window. So we will not know in what tone or in what command, whether it is a command or whether it is a request uh, to close the window or to open the window. So we'll have to know the proper punctuation in order to know whether it is a request or it is a order. So here question marks after the sentence indicates that it is a request because could you close the window for me please? This without any punctuation provides the meaning of a request because it involves please. But here there is no please, but it has an punctuation, which means that close the window, will you close the window for me? It actually means that. So this seems like a request rather than a command. But when a full stop is given instead of this question mark, then it is going to be more of a command. Close the window, it is a command. So all these things has to be analyzed by the analyzer. So pragmatic analysis does this, and it more likely depends upon the context of the situation in which it is in. Let us take an example of it rains today, and there is a football match today. It does not give any meaning because since it rains, a football match cannot be played in an open stadium. So it depends upon the situation. So we'll also have to know the situation whether to know whether it is correct or wrong. So these are the five phases that is involved in processing of any natural language, and more uh, like more more accurately we'll be seeing about this syntactic analysis in this video. So what is a syntactic analysis? Syntactic analysis, as I've already mentioned, it is used to check the grammar of a sentence, to know whether it is arranged structurally, the structural arrangement of the words, the order of the words is proper or not. That is what this syntactic analysis, the syntactic analyzer actually does. So, first, the the complete sentence is broken down into different words, and these words are the component parts of a sentence and are called as constituents. And these constituents has to be defined properly, and the combination of these constituents, the arrangements of these constituents should be structurally, grammatically correct. So this syntactic analysis is used to check the grammar and also the word arrangements, as well as how the relationship between these words is actually described. It analyzes the text for a meaning by comparing it to a formal grammar rules. There are grammar rules in which these has to be arranged. So these uh, the sentence has to comply with all those grammar rules. For example, let us take hot ice cream. Hot ice cream does not make any sense because an ice cream can never be hot. So this is not grammatically correct. So it is grammatically incorrect. So this analyzer will thus reject the sentence. So this has two tasks. The first is breaking down the sentence into its constituents. These constituents are nothing but words. The sentence is divided into different clauses or phrases or words, and then these words should be labeled properly to know whether it is formed correctly, it is represented correctly. So that is what is the task actually involves. So first, the parser. Let us look into the parser. This so what this parser actually does is it just reports any syntax errors that occurs. So it helps in recovering from commonly occurring error, so that the sentences are error free. So as I've already mentioned, the lexicon analyzer just breaks down the sentence into different words, which are called tokens. So these tokens are then passed to the parser, and the parser checks whether it just checks the labels and checks for the grammar rules, and checks whether all these rules, like all these words or the sentence follows these grammar rules, and this then tells whether it is grammatically correct or incorrect. And symbol table is used for this as it stores the information on all these occurrences and all. So first there are four different levels. The first is the sentence level, clause level, phrase level, and word level. So the sentence level is nothing but the sentence. Clause level is we're just dividing the sentence into different clauses. That involves the clause level. And the clauses are divided into different phrases. And these phrases are divided into words. So this is called the rank scale, ranging from the sentence to the word being the smallest entity. So this can be represented in two different forms, one in label bracket form and the other in tree diagram. So first let us look into the label bracketing. So first, as I've already said, let us take an example of the sentence, the snake killed the rat and swallowed it. So it is going to be the sentence, so it stays in the sentence level. So this is the sentence level which has the sentence, and in the next clause level we are just breaking down the sentence into different clause. So what I'm going to do is I'm just going to divide the sentence to two different clauses. The snake killed the rat and it swallowed it, so it's going to be two different clauses, and these clauses are again going to be divided into different phrases, which is going to be the snake killed the rat. It's killed the rat, it's going to be the second phrase, the rat being the subphrase of the second phrase, and it swallowed it. So this is the phrase level. And again, dividing the phrases into different words, it's going to be the individual words or the tokens. So it's going to be at the fourth level, it's going to be the snake killed the rat and swallowed it. It's going to be the last level. And then we are supposed to label all these things. All these brackets are supposed to be labeled. So first it's going to be S1, which is the sentence, and the next is the clause level. We are just mentioning the clause 1 as S2 and the clause 2 as S3. And in the next level, we are just going to label it as the phrases as NP, which is noun phrase, VP is a verb phrase. The snake is actually a noun, right? So it comes under the noun phrase, and killed is a verb, so it's a verb phrase. And again, the rat is a noun phrase, and swallowed is a verb, so it's a verb phrase. And again, it is a noun phrase. And then the words are divided from the phrases. So the now we are just going to mention the part of speech of all these different words. The is a determinant, snake is a noun, killed is a verb, the is a determinant, and rat is a noun, and is a conjunction which is defined as God here. It is going to be the noun. Swallowed, it is a verb. It is a noun again. So this is how label bracketing actually works. So we are just going to divide the sentence, and then we are just going to bracket them, and then we are just going to label them. And next comes the tree diagram. So tree diagram is more of a visual representation of what we have what we saw in the label diagram. It actually arranges all these words into an hierarchy, so into a tree. So this tree contains the sentence clause, I'm sorry, the sentence as the root, and the notes will be the clause or the phrases, and the terminal is going to be the word level. The words are going to be the terminal notes. And S1, as we've already seen, this S1 is going to be the sentence level. The snake killed the rat and swallowed it. It is going to be this at the sentence level. And S2 is going to be the snake killed the rat. S3 is going to be and ate it. Okay, so it's going to be S2 and S3. And this S2 and S3 are again divided into different phrases. Noun phrase and verb phrase. Noun phrase and verb phrase. And these phrases are again divided into different words with all these parts of speech given. The is a determinant, snake is a noun, killed is a verb, the is a determinant, rat is a noun, and is a god, it is a noun, swallowed is a verb, it is a noun. So this is the hierarchical structuring of what we saw in the label structure. That's it. So that is what it actually does. So this NLP algorithms can be used, and basically more likely for the general context free grammars, CYK algorithm is best suited. And these CYK algorithm is like no other algorithm can beat CYK algorithm, and this are faster algorithms for the restricted grammars. So these are the NLP techniques that we'll be using, and this is what is basically a syntactical analyzer. What is a syntactical analyzer does? So this is what the basic idea of how does this work. Now let us move on to the project. So we are going to work on the project called Employee Link. So this is a project that helps in making the government services accessible for all the people. This uses large language model and also the BERT architecture to train the data. So maximum number of data are loaded into this model, and then this data are actually taken from the government sites to answer the questions according to the needs of the users. So this data is then fed into the model, and the ML algorithms, that is the LLM and BERT, are applied to uh, answer the questions effectively. So first, what is this LLM, large language model? It just is it is one of the key component of NLP. It just takes the data to understand and make the text sounds like it is written by a person. So this is what this LLM does, and this works for a large amount of data. An example for this LLM would be ChatGPT, and BERT is the architecture that we are going to use for this. So BERT architecture, it is especially useful for the for the algorithms that use question answering thing. So we actually think that it is a pretty good idea because it is accessible for all the people around the world, around the country. So in India, there it should be accessible. Like the government services should be accessible for all the people. So this idea actually makes it accessible for all people across the country, and also it is efficient because government agencies get a very lot of questions. So automating the process of this answering thing would be more efficient in terms of the government employees and also for the people, because it would be easy for them to get the access from the internet and then know the answers for them from the internet. And also it is scalable. We can just expand it according to our needs, and then we can just modify them accordingly. And it is also easy to use because people find it very easy to surf through the internet rather than standing in the queue and waiting for hours. And in conclusion, we would like to say that our project has the potential to make the government services accessible for people more effectively and more efficiently. And we are going to design this project carefully, because the privacy of both the government and also the public should be maintained properly, and the quality should be delivered more accurately. So that is why we think that this project is going to be a very good project, as it also involves NLP algorithms also. So thank you.